Hey, what is up guys? We are back with a tutorial on the mobile game. So last episode we actually created this little pause menu here that we use to go back and forth to the main menu and back to our game. In this episode we're actually going to make our player move. So this little guy here is going to have a script that is going to make him move depending on our inputs. Alright, so let's go ahead and create ourselves a new C# script that we're going to apply to this guy. Now I like to call my movement script motor. So I'll go ahead and create this new script and let's actually open it up, see what we can do for this guy. So as always, we are going to zoom in on this. We are also going to wipe it up, clean it up as much as we can, and we are going to get started. So let's start by adding some values we know we're gonna need. So some kind of public float, move speed, and we can be setting that to 5, I don't know, we'll see eventually, but make sure you make these public so we can actually tweak them while we're playing the game. And then after that, we are going to have one called drag. So how exactly is the floor affecting your player's movement? So the friction ratio, pretty much. After that, let's go ahead and set another one that I'm going to call terminal rotation speed. I'll set that to 25, and you will see what this does in a moment when we actually instantiate our rigid body. Or actually, we're not going to instantiate it, we already have it, but we're going to be assigning these little stats here to our rigid body. Okay, talking about rigid body, let's actually have a reference to that one. So, we are going to create ourselves a private rigid body that we're going to call something like controller. And this is where we actually do our movement. So whenever we want to add a movement to our ball, we're going to be doing it through the rigid body itself. So that's going to be pretty much it for the fields we need to declare. Let's actually go ahead and declare ourselves a start now. Again, Unity callback, make no mistake in this. And we're going to say controller is equal to get component rigid body component. Just after that, we'll do controller dot max angular velocity is equal to terminal rotation speed. And finally, controller dot drag is equal to drag. All right. So this is going to be pretty much it for our start. Now we have a reference to our rigid body, and that's pretty much all we need actually to make this work. So every single frame, we are going to look for the player input. Now we haven't started coding the joystick just yet, the virtual joystick for our game, but we can still test out our game using the inputs from the keyboard itself. So I'm thinking about the arrow keys or the WASD keys. So that's what we'll be doing right now. Actually, we're going to create ourselves the update class, not class but function. This is being called every single frame, so 30 times a second if you're running at 30 FPS. And inside of here, we are actually going to pull for the input. So we're going to check, are you pressing on any keys right now? And if so, we're going to store it inside of a vector3 that we'll then use to move our ball around. So let's do just that. We are going to start by declaring ourselves a new vector3 inside of our function. So this is a scoped field. I'm going to call it dir for direction. When we actually declare it, let's put it on 0, so we start off with a really clean vector3. After that, we're going to say direction.x is equal to input.getAxis, and we're going to get the horizontal axis. We're going to do the exact same thing, but this time for the z-axis. Don't mistake this for the y-axis. We're actually going to be using the z-axis, and that is because in Unity the y-axis is used for up and down, and the z-axis is pretty much used for forward and backward. So the y-axis is used for gravity most of the time. Okay, and since we don't want to be moving on a vertical plane, we want to be moving on a horizontal plane, we're going to be using direction.z instead. Okay, so one last thing we need to do is check, is your vector bigger than 1? So if dir.magnitude is bigger than 1, we're actually going to normalize it. This way we don't actually go faster if we are on a diagonal axis. So you see this sometime in really old games. If you go forward, straight forward, you go to a certain speed, but now if you go on a diagonal axis, so say forward and right at the same time, you actually run faster. So we're gonna avoid that by normalizing our direction vector. Okay, so once we have that direction vector, once we have all the inputs we want, we can actually just go ahead and use them on our player. So what we're gonna do is say controller.addForce, and we're gonna be adding the direction, so there, times move speed, just like this. And as small as this script might look, it actually works just fine. So if we actually go on our player, on this guy here, and we press play, now I'm using the WASD keys, as you can see, he actually moves around. So this could stop right here. Actually, we could be pretty much done with our movement script, but we're gonna go a little bit further this episode. We're actually going to start coding our camera as well. As for the camera, what I'd like to do is actually have the camera set on 4 different axes, 4 different set axes. So the player is going to be able to rotate his camera around only 4 different points. We could be making it a free camera, but I don't really think it's going to be that much of an improvement. Of course, it's something we can consider a little bit later on. We already have a guide on how to do a third-person camera, so if you prefer doing that, you can go ahead and check out the guide. But I'll be using 4 different axes right now. So let's actually get started with this camera. What we'll do is we are going to create ourselves a camera motor script. So as you can see, I've just created mine. It's over here. I am going to open it up, and we are going to clean this up like we always do. So let's clean it up. And pretty much what we are going to need for this camera script, first off, is going to be a transform lookat. So which object are we looking at right now? We are also going to need a private vector3 offset. Maybe a distance as well, so a private float distance, which is going to be the distance in between the player itself and the camera. After that, let's do private float y offset, and let's give ourselves a 3.5 in y. Okay, let's start off by creating a start function. So whenever this camera boots, whenever the game starts, we're going to say offset is equal to a new vector3, and these values are pretty much just whatever you want to put in there. Mine are going to be 0 y offset, which is 3.5, and I'll give mine a -1 f times distance, just like this. So now we pretty much put the camera right behind, well, in the back of the character, in the back of the ball, and we also elevate it by 3.5 f, so we get a we're not on the floor level basically. Alright, so let's keep going. We are going to go create ourselves an update. So private void update, and in here we're going to say transform.position is equal to lookat.position plus the offset. Alright, so we pretty much already have a camera that is following our player around. Let's go back inside of our game. Choose your camera, make sure you assign the lookat field. I'm going to drag and drop my player right inside of the lookat field. Press play on this, and this is what we currently have. Alright, so like I said, what I'd like to have is the possibility to actually rotate my camera around, but on 4 different axes. So now what I'll do is I'll actually create a function inside of my camera that will be called, it's going to be a public function, so public void slide camera. And we'll take in a boolean as parameter, so I'll call this one left. As simple as that. So basically this function is going to be called whenever you want to slide your camera either right or left. Now I take in a boolean parameter, so I actually know are you swiping left. If you're not swiping left, but well, by default you're swiping right. So I only need one parameter to know which direction the player is actually swiping in. So it's actually a really simple function. So all we'll do is if left, so if you're swiping left, we'll say offset is equal to quaternion.euler, and we will rotate by 0, 90, and 0 times ourselves. So this is how you actually rotate a vector in Unity. So you pretty much just multiply it by the quaternion of your rotation. And then we'll do else. Well, that means you're swiping right. So we'll do offset is equal to quaternion.euler. And in this case, it's going to be 0 minus 90 and 0 in z as well times the offset. And let's actually try it out in game, but in order to do that, we actually need some inputs, some kind of way to trigger that inside of our game. So in our update up here, what I'll do is I will create a if statement. So if input.get key down, key code, I'll be using key code, I'll be using left arrow in this case, since I'm already using WASD to move around, so I'll be using left arrow. Close this up, and we'll say slide camera through, because we're swiping left, basically. Else, and this cannot be a simple else, so we have to do a else if input.get key down. Again, key code dot right arrow. Oops. Right arrow, and we'll do slide camera, and I can't write at all today, so slide camera false. Alright, so I'll say it once more, but these inputs are eventually going to be changed for actual input that you can use on your phone. Okay, let's go ahead and press play on this, see what kind of result we get. So I'm moving around, and then I press on the left arrow. This is what we get. Press it again, same thing, again and again, and we're back. So basically we can do a full rotation around our player. Of course, there is some error in here. We actually like to see our player, so we'll go back inside of our update function, and we'll say transform.lookAt, and we'll send him the lookAt object. So transform.lookAt, and it takes in the lookAt. Not look at it, takes in a transform parameter, which is pretty much what we tell him over here. Okay, let's try this once more. Pressing left, and as you can see, we're now moving around our player. And now, since left is also the secondary key for input get axis horizontal, then we also move just a little bit. So that's going to be annoying, but just tell yourself that these are not the final inputs. Okay, now one thing you probably notice if you're actually doing this in the real time is that if I put my camera looking on the right side of the object and I'm pressing forward, it goes on my right, because the player is still using the world coordinates, and we want him to be using the camera's coordinate instead. So we'll actually go back and fix that right now. Actually, we are going to open up the motor script. Now we are back inside of our ball motor script. This is the movement script for our player, and we actually need to put something right here. So right in between the normalize and where we actually add the force, we need to rotate our direction vector with the camera. So the way we're going to do this is, first we're going to need a reference to the transform of the camera. So we're going to go up here, right below rigid body, we're going to say private transform cam transform. This way we can actually have we can constantly have a reference to our camera without calling it using the line I'm about to type right now. So inside of our start, just go ahead and type in cam transform is equal to camera dot main dot transform. So what happens is, using camera.main, we actually get the first active camera that has the main camera tag on it, which by default is this one. As you can see, this is named main camera, but most importantly, it has the main camera tag. So it's going to get this camera, and then fetch its transform. So it's going to get this very component over here. Right. Once that is completed, it will store the result back inside of cam transform, and we will now be able to use it inside of our update function. We will create a new vector3 in here that we'll call rotated direction is equal to cam transform dot transform direction. Now transform direction is going to take the direction in the local space and transform it into world space using an actual direction. So in this case R is direction, just like this. Now we have a rotated vector. So this could work right here, but we're actually going to do something in between this line and the add force. Now the reason is whenever we rotate our movement, we might actually get some y-axis in there because our camera is not looking directly in the straight. It has a slight angle, and we do not want this slight angle to affect the y component of our bulb, basically. So we don't want to be like modifying the gravity when we move around with our camera. So we have to kill the y component. The way we do this is by saying, taking the same exact vector, I'll do rotated there is equal to a new vector3. So new vector3, and we're going to do rotated there dot x 0 in y and rotated there in z, just like this. Now we've just absolutely killed the y component of that vector, but we might have reduced the size of it, which is not something cool either, because now we're losing some movement, or I mean losing some speed. Now we fix this by saying rotated direction is equal to rotated direction dot normalize times direction, which is our original input vector, dot magnitude. So basically we turn this into a unitary vector, and then we multiply it by the original magnitude. So if our original direction was, say, 0.75 in length, then we just turn this into 1 times 0.75. So we get the original length back, so we get the original speed again. And we can finally use this rotated direction back here inside of our add force. Alright, let's actually try this out. Press play on the game, and I am moving right and left. Now I'll rotate this around, and it's now working on these axes as well. Alright, so that's looking fairly great actually. We might want to be, well actually we want to be putting some smoothing on this camera, so this is going to be a fairly long episode, but at least we get some good stuff covered. Alright, so to tackle this smooth camera thing, what we're going to do is pretty much the same exact thing we did inside of the smooth camera video. We are going to go up here, declare ourselves a private vector3 that we'll call desired position. So this is the position we should be at right now if there was no smoothing at all. We're also going to need a private float smooth speed, which I'll set to something like 7.5 for now. And like I've just said a second ago, desired position should be the position where we need to be at if there was no smoothing. So what we're going to do is take this up here and modify what we had a little bit earlier down here. So where it says transform.position, this is now desired position. And now transform.position is equal to a vector3 dot lerp, and we're going to lerp in between my current position, so transform.position, and the desired position. Now the float we're going to give it in parameter is going to be smooth speed times time.delta time, and that should give us a some kind of smoothing effect. If we press play on this, and I just go like this, as you can see we have some kind of smoothing. It's nice looking, but the camera is looking a little bit too low in my opinion. So what we're going to do is down here in the transform lookat, so this function lookat is actually looking at a point in 3D world. Now I know we gave it a transform value, but if you look at the overloads, we can actually give it a position in the world to look at. So we could give it directly a point in the world you could look at. So that's exactly what we're going to do. So we can add some kind of offset to this value. So we're going to say transform.lookAt, and in parameter, lookAt.position plus vector3.up times the y offset. So we're going to take 1 times the y offset, which is 3.5. So we're actually going to look 3.5 higher. Is that how you say it? I don't know. Let's actually have a look. And that's yeah, that's obviously big. So let's just do +1 for now. So plus vector3.up like this. And let's press play. And it doesn't look too bad actually. So I like that. Okay, and one more thing before we actually end this video, and this one is quite awful. It's a fix we need to do, and you probably can't see it right now, even though this is a YouTube video. You probably can't see it, but it's really choppy. It's really lagging like hell, and that is because we are moving the player using the rigid body. That is physics. So physics is calculated 60 frames a second, no matter what, and that's just how Unity works. So our camera doesn't update as fast. Our camera is actually on a normal update cycle. So what we're going to do is actually swap that update cycle. We're actually going to put it inside of a fix update. So below update, let's actually create ourselves a private void fix update, and down here we are going to we're going to cut these three and put them inside of the fix update. Now again, fix update is a callback from Unity. You are not allowed to make any mistakes in the spelling of that, so capital F, capital U, and it is being called automatically by Unity itself. So it's being called on the same thread as the physics. Let's hit play on this. Hopefully it's going to look a little bit better. And now the camera is updating on the same rate as the player itself. So it's actually looking quite good. All right. Well guys, we got a lot covered in this video actually. We made the camera and we made the player. I didn't think that we'd have the time to do that, but we just went for it. So I understand if this was a big video, just give me feedback. So if you enjoy having bigger videos, I'll just keep making these a little bit longer. But if this video gets confusing, which probably it probably is confusing, it's confusing me at a certain extent. So if this gets confusing for you, please leave me a comment in the comment section below. Also, if you have any question or suggestion, just go ahead and leave that down there as well. And if you enjoyed this video, please leave me a like. I really appreciate that. And I will be pretty much making these until we're done. Right. Alright guys, so thanks again for watching, and I'll be seeing you in the next episode.